Okay, so in today's class, we'll be looking at performance optimization and security. And we'll be looking at synchronous code, memory management, compilation, profiling, monitoring, and logging. Optimization techniques. Actually, before you take your project to production or your application to production, your server actually to production, you have to optimize it and then sure everything is working as expected so that your users will have a seamless experience. So in doing all of this, we have to bring together so many things in our application. And for asynchronous code, we've been writing asynchronous code and we make sure everything is almost asynchronous in our code. And if you come over to tasks, you will see that everything here is asynchronous. This is an async wrapper. So this function is asynchronous and everything in here is asynchronous. Writing to the database, reading from the database, and every other thing is asynchronous. So that everything is well connected and working properly. So we'll not be talking much about that because at least we know what asynchronous code is. And database query optimization, I earlier said something about this. And in Prisma, actually, I'm not teaching you Prisma, but we're using Prisma in this project, and you've known the basics and almost, or you are an intermediate in Prisma, so you can go ahead and explore Prisma docs and get to understand other things. What in optimizing queries, let's say we want to optimize this get task or this get task query. So let's assume we have a table, a user table, and all we want to return from that table is let's see the task table. I want to return task description. Only the task title and description from this get task. We display the task and then see the title and the description. So what we do here is we just go here and see either includes or see you will just take, let's say, includes, and what we want to include here is the title and the description of the task. And you can see it's an object executed true, description true, like so. So we just want to fetch the task for what we want to. Let's assume these titles and descriptions are like they're connected to this task table. So we want to include them in this query. But if we don't want to include them, we will not use the include. A minute, please. I'm back. Sorry about that. So optimizing queries, let's assume when you have nested, let's say you have a table that is connected to this, connected to your task, and you want to fetch your task, you have to include those the other table. If not, it will not. Let's say you have another table of a user. You see here, user. As you can see, user, true, something like that. If you don't want to, if you want to include the user as well, you say user true. And if you get the task, the user will be also included. But if you don't want to include the user, you just want to get the task alone, you will leave the user and then you get only the task. It's well optimized. And if you don't want to, this other query, I've forgotten, is it a tick? Not really, but forgetting the query. Maybe we should check the Prisma docs. Sorry, but I've forgotten the query actually. Prisma. And I think I should find the query in the playground. Prisma client. Okay, so I can't seem to find it. It should be, yes, okay. I've seen it. It's just a simple name that I've forgotten. Actually, we have here, let's say we want to include the user and we want to return, we want to say select, we want to only return the title of the task and the description as well, like this. So we've optimized our query. There's no overfetching. We just return what we need. We just return only the title and the description. And this is great. This is part of our query optimization. We want to include the user, but if we don't want to include the user, we remove it. And then we'll have our task, and this task is returned with only the title and the description. And when you fetch this task, you will not find the ID or the completed there. You will only see the title and the description of the task. So that's great. If you want to learn more about query optimization with Prisma, you go to the documentation, and then there are some helpful tutorials there that you can get your hands on. Yeah, go ahead.
Okay, during the last project, I discovered that you cannot select and include together in Prisma. Like if I want
Yes,
to do that and I want to select from maybe some fields from that particular from the base table.
yes, that's true. You cannot select and include. You can only use select. As you can see, you have user here and user ID. You have user true, like this. If you want to optimize your query, return the title, description, and the user, you cannot use include. You can just use title, description, and user. If you're using select, you cannot use include. But if you're using include, you cannot use select at the same time.
Okay, okay.
Yeah. So I think that's all about query optimization. Our app is not that complex that will go ahead optimizing queries, but I think that's all. And the next on the list is optimized libraries. All the libraries we are using here are optimized. Before a library is put out there, all these libraries we are using, let's see the frameworks, the libraries, and everything, the third-party modules, all these Prisma clients, Prisma, JSON Web Token, and all of these, they've been tested and then optimized for production use. .env and all of that, they've been tested and optimized. So before any package is released for use in production, it is always tested and then optimized for usage so that it doesn't cause problems. And that's the reason why they keep releasing subsequent versions, like let's say Express XS Sanitizer, we have version 1.1.6. We have one major release, one minor release, and 6 patches. And for Helmet, we have 7 major releases and 0 minor releases in the version 7 and 0 patches. And when you come to, let's see, Express, we have 4 major releases, 18 minor releases in the version 4, and then 2 patches in that version 4 as well. And all of that, you can see the JSON Web Token, 9 major releases and 2 patches. Then Prisma, 5 major releases, 3 minor releases, and then 1 patch in the version 5. Okay, so all these, new versions are being released so as to optimize and ensure security in all those libraries and packages. So every package you see people using out there, you can go ahead and make some research to make sure it is optimized and suitable for production use. If not, you avoid it. So you must make sure you are using optimized libraries in your application so as not to make your app a kind of slow or make it flag or something like that. Make sure you use optimized libraries. And memory management. Okay, so I think I've prepared some docs for us. In our docs folder, we have memory management. In memory management, I think there's memory management is an Express application. Sorry, memory management in an Express JS application is crucial for ensuring that your application runs efficiently and doesn't consume more resources than necessary. So below are some steps to consider when you're addressing memory management in your Express application. So you have to identify memory leaks. So by identifying memory leaks, you start by monitoring your application for memory leaks. Tools like NodeJs built-in head bump or third-party tools like Node MemWatch can help you identify and analyze memory usage. You can go ahead and research on these tools and try using them to help identify memory leakages in your application if there are any, or if none, that's cool. And then optimize data structures. Before using any data structure, you carefully choose data structures. Use efficient data structures like map or set. When storing data in memory, avoid using global variables to store large amounts of data, as it can lead to memory leaks. Okay, so I earlier said something about using global variables in your application, and they've stated here, so I've also stated here for you. When storing data in memory, you avoid using global variables to store large amount of data, as it can lead to memory leaks. And that's true due to the loose nature of JavaScript. And then minimize object creation. So creating too many objects can strain memory. Like reuse objects when possible and avoid unnecessary object creation within the hot code part. So code reusability is always advisable. Make sure you create code that is reusable in your application. If possible, you create one object and then you reuse it in the whole of your application rather than creating those objects. Okay, it's great. Then use stream and buffering. We're handling large files or streams. Use NodeJs stream for efficient data processing. This avoid loading data to memory at once. And when we were learning about streams, we discussed about this, how we can handle large amount of data with streams. We read the data chunk by chunk and not all at once. So streams are useful. We don't just need to read data at once into memory so that our application will not crash. We read it chunk by chunk into memory. You understand? Okay, and then we have middleware and request handling. Be cautious with middleware. Some middlewares can consume memory, especially if they pass or buffer request bodies. Use middleware judiciously and only where necessary. You just don't use middleware. You use them when necessary to solve specific problems. You just don't populate the whole of your application with middlewares. Use them with caution because some middlewares consume memory and that may lead to poor application performance. So limit concurrent requests. I think we talked about this one. Ensure that your app doesn't process too many concurrent requests as each request consumes memory. You can limit this using tools like Express Rate Limits middleware. And I think we did something like that. Express Rate Limits. Yes, here it is. Express Rate Limit. I think this is in 15 minutes. If you make up to 100 requests in 15 minutes, you get this response. So many requests, check back in 5 minutes. Okay. So make sure you limit concurrent requests. Then 7th, caching. Caching, implement caching for frequently accessed data. Caching can reduce the load on your server and minimize memory usage. And you see, in our next class, we see how we can implement caching in our application. We implement caching with Redis, and then we'll see how we can catch data and then resend it on subsequent requests without having to query that data from the database. And then connection pooling. If your app uses a database, ensure that you use connection pooling to manage database connections efficiently. This helps in reducing connections and reduces the memory overhead of maintaining multiple connections. And I think in retry write through and the majority, I think MongoDB implements that automatically. And for SQL, MySQL and PostgreSQL, you will see pooling. There's an option for pooling at the end. I think every server has that, and then you have to add it, and then you set it to the value you want, customize it the way you want it to behave. And number 9 item on the list, clean up resources. Explicitly release resources when they are no longer needed. Closing database connections, file handles, and other resources. We're not opening any files in our application, but it's advisable that when you open a file, you manually close it. Don't wait for the application to automatically close it for you. It's advisable to manually close files. Okay, so that's great. Then optimize dependencies. Review the dependencies you use in your Express app. Some dependencies may consume excess memory. Consider alternatives or optimize your usage of them. Yes. If you notice that a dependency is consuming a whole lot of memory, maybe you limit using them, you use them when necessary, and then avoid using them at all if necessary, if possible, because of the memory consumption and all of that. So you have to take note of all of these. So monitoring and profiling. We'll look at monitoring and profiling in just a minute, but we'll just talk briefly about it. Regularly monitor your application's memory usage and profile its performance. Tools like NodeJs, APM, application performance monitoring solution can help with this. Later in today's class, we'll see how we can use Node Inspect to at least inspect a simple JavaScript file. We'll start from there so you can go on your own and then explore all of that. So version upgrades. Keep your Node.js and Express version up to date. Newer versions often include performance and memory usage improvements. I think I discussed that when we're talking about, I think, optimized libraries, right? I said something about updating all those libraries and their versions. So when they're updated, it's advisable you update them also in your application so that your application will up to date with the latest releases, because those releases come with better security and better performance as well. And scaling. If your application experiences high traffic, consider horizontal scaling by using load balancers and multiple instances of your app. This can help distribute the load and manage memory more efficiently. In our next class, we briefly talk about load balancers, and if possible, we try to implement load balancing in our application so we can see how everything works. That's if possible. If there's no time, I think we'll just discuss about that, try to look at some diagrams that illustrate load balancing, and then we'll see how we can try to implement load balancing as well. Yes, serverless or containerization. Depending on your use case, you might consider serverless architectures or container easy Docker to manage resources more efficiently, as these platforms often provide automatic memory management. Later on in this course, we learn how to use Docker and, if possible, introduce Kubernetes K8. Okay, so I think that's all from memory management. You can always come back to this and try to read it and understand. I can even make a little more research to understand better. Okay, so we're done with memory management, and the next item on the list is compression. Okay, so let's take a look at that. So what is compression and why is it needed? Compression MD. Okay, so we have compression here. Compression is an, I think I should just increase this a little bit. Like, okay. Compression is an Express.js app. In an Express.js app refers to the process of compressing the response data sent by your server before it's transmitted to the client's browser. This can significantly improve the performance and reduce the bandwidth consumption of your application, especially when you're dealing with large volumes of data. Express provides middleware to enable response compression. Here's how to implement compression in Express.js. So first of all, you need to install the compression middleware for Express. You can do this using the npm or yarn. That is npm install compression or yarn. Add the middleware to your Express app, import the compression middleware and use it in your Express app. And okay, I forgot to add this is a string, so that's actually a mistake. Okay, so you import Express and you import compression, and you use your compression middleware here like so. So number 3, you configure your compression. You can configure it to match your needs. You can configure the compression middleware to suit your needs. Here are some common options. Filtering. You can filter which responses are compressed. For example, you might want to compress only responses with specific content types. App use compression filter should compress, and this your should compress function. Request headers X no compression. Yes, you should not compress any response with this header. Return compression filter like so, and then threshold. You can set the threshold option, which specify the minimum response size in bytes for compression to be applied. So response is smaller than this threshold will be compressed. So in this case, the threshold is 0. So any response smaller than 0 will be compressed. And with the compression middleware in place, your Express app will automatically compress responses based on your configuration. Here's an example of a route that serves compression JC data. Okay, so now we'll try to implement this in our application and then create a middleware for that. So let's come down here as npm I compression. Okay, so we've installed the compression middleware, and then let's go back to index.js, and we import compression. I think this should be after .env, import compression from compression. On top, I think after this, limit express session. let's just app use compression without any options. As you can see, the options are optional. Okay, so now let's see npm run dev. Let's open up Postman. Let's zoom in. Zoom in Postman. Okay, remove that. Add a request of http /local host 3000/tasks. I think our server is not running, so let's start our server. Okay, it's running actually. Send this request. Get request 401 unauthorized. Okay, let's log in. Here AC paste. We see /session /login, and in the login, the body come here, say raw, and this is of type JC. So actually specify a JC body. Say username 185, password 85, like so. Then we send. Okay, post, it's a post request, not a get request. That's why it's saying the route is not found. Okay, send. Okay, response of 200, login success. So if you come back here, now we can see the cookie, but let's send the request once more. Now we can see we have 7 headers. The cookie is automatically added. And we have a task here, just a single task with some description, text task, user ID completed is false. Okay. I think we have headers here. About 20-something headers of content security type, S connection, and there's a particular header I want to show you. An e-tag. E-tag. Identify a specific resource version and connection keep alive. Okay, so here the header user agent, and accepts anything, accept encoding, gzip, deflect, and PR. So this accept encoding, you see that the accept encoding header is added to indicate to the server that Postman client supports a defined list of content encoding or compression algorithms as response. So actually, this compression is compressing this as is compressing them as gzip files. It will compress it and send it to the client as gzip files. And as you can see, Postman will accept it. You can remove the header or enter a new one with a different value. Doing that may not accurately render the response with the app. Okay, so now, yes, rate limiting is yes, rate limit. It's actually here. X rate limit reset. X rate limit remaining. Yes, X rate limit. It's a maximum of 100. So we've sent about 4 requests, so it's remaining 96 in 15 minutes. So if you continue to send this in 15 minutes, actually we'll, get that response. So that's great. our home. So now what I want us to do is to go back, and we can actually customize this to, can make this a middleware. I will say if the request headers contain X no compression, we will not compress the response of that request. So we can come here, but before that we need to come to our middleware. Let's see a compression JS middleware. See function. What's the name again? Let's just follow this one. Should compress, or let's okay. Yes, this says should compress, something like that. Let's say should compress. Yes. Come here. Should compress, and this will take in the request response parameters. And before this, import compression from compression. See, if request headers not really okay. So let's just check this out. What do you have here? Okay. But if request headers, if the request headers contain this, then we will return false. If not, okay. If request headers, we have X no compression, return false, else we will return, I think it should be below, return compression filter. What are filter? Request. It's an object actually. They will see what is the object taking. Put a filter request. Okay. An object of a request response. Like this, they will export should compress. It will come down here. We import it on top. I think let's just see here. Import should compress from middleware express.js. Then we come down here in the compression, we see should compress like so. Okay, we've added this middleware. Now, if we come back to Postman, we don't want, let's go back to controllers, session out. We can simply say, in the login, here you can say res. I think yes, do something like that. If we don't want to do the threshold, that we set headers in the response. We say we have our response right here. So response set headers, an object of okay, let's just remove this and use Postman to do this. We can come here and in our headers, we have X no compression. I will set it to true, like so. Okay, so we send this request again. Okay, so we have our response here. And everything is working as expected. No errors. We still have our tasks. We have our cookie. Here's our cookie. The cookie we're using, the path is slash, the expiry date, the HTTP only secured is false because we're in development and it's not secured. Okay, so we're simply saying the response to, we're setting the headers to this, and we're simply saying the response to, we're sending this headers, this XNode compression headers together with this request. I was saying the response to this shouldn't be compressed. When you're responding with this, you shouldn't compress this response of these tasks and all of that. So it depends on the use case, how you want to do it. And you can even set the threshold and all of that, anything you want to do. We can easily come here in the compression. Okay, index, set the threshold to, we don't have any reasonable amount of data that we want to compress, but if we're pushing our app to production, and then maybe we have different users wanting to request a task on a regular basis, and they'll have like 100 tasks, 200 tasks or more. So we want to compress it and then send it back to them. So that's where this is useful. You can actually come here and see threshold. I think this should be an object. Should compress. We have options. Threshold of 0, like so. So we have our should compress function from our middleware, and the threshold, say, let's say any five. Let's set it to 5 or 10 for optimization purposes. And if you come here, you will see that this threshold is saying you can set the threshold option which specify the minimum response size in bytes for compression to be applied. So if you come back to Postman, we have 1.12 kilobytes. So this will not be compressed. If it's less than 10, it should not be compressed. If it's any response size less than 10 kilobytes, shouldn't be compressed. So we've set it to 10 here, and if you come to Postman, you see that this will not be compressed. This response is less than 10 kilobytes, so it will not be compressed. So this is for optimization purposes. Okay, and I think that's all for optimization. We've created an view. We've created optimization. A compression middleware to use in our application, and we're checking for the request XNode compression header. And if it contains XNode compression header, we don't want to compress the response. We just want to filter the response here and send it back to. If it does not contain the XNode compression header, we want to compress it and then send it back to the client, like so. Okay, so that's great. What's next on our list? Profiling. Great. Profiling. So what is profiling? Come back here. Where is this? Profiling. Okay. So I think let's move back to docs, and then we have profiling. Just a short note. Profiling in the context of software development is the process of tracking and resolving bugs, measuring and analyzing the performance of your application to identify bottlenecks and areas where optimization is needed. It allows you to pinpoint which part of your code contain errors and are consuming the most resources such as CPU time or memory. Okay, so in NodeJS, we can use the node inspect to profile our application. Now, this when developing your, we normally use the console log function to actually debug and profile our application. And if there's any error, we log it to the console and do debug. But as your application grows bigger and bigger, errors that may be unfamiliar to you. So using these profiling methods, like the node inspect, it's a built-in tool, and we have some shortcuts like the C, the N, and S. So C is for continue, that is continue execution to the next breakpoint or the end of the program. That is if you set breakpoint. But if there are no breakpoints, the N is for next, move to the next line of code. That's if there are no breakpoints. If you enter and hit enter, move to the next line of code. And S or step, that is C or cont, C-O-N-T, C or cont, C-O-N-T, that is continue. And then we have N or next. If you don't want to enter only N, you enter next and hit enter. If you don't want to enter only S, you enter step and hit enter and you step. By default, we only step through code in the block or scope where why we're debugging. But if you want to step into a function, you just enter S and hit enter, or you enter step and you hit enter. So actually, in Node.js development, tracing a coding error back to its source can save a lot of time over the course of a project. That is, but as your program grows in complexity, it becomes harder and harder to do this efficiently. So to solve this problem, as I earlier said, developers use tools like a debugger. There's a program that allows developers to inspect their program as it runs by replaying the code, let's say line by line. That's if you're not jumping to a function that or continuing execution. The next command replays the code line by line and observing how it changes the program state. So debuggers can provide insight into how a program is actually running. And it makes it easier to find bugs. Yes, it makes it easier to find bugs because in a process where you make a mistake, there's a bug in your project, by merely looking at the code, you may not be able to actually figure out the bug. But using the debugger, you move to your line, move through your code line by line and able to identify those bugs. So a common practice programmers use to track bugs in their code is to print statements as the program runs, like the console log, the console debug statement in the module or something like that, the console error, console, all of them. We use the console function with console objects with its methods, the debug, info, error, log, and all of that to use it as a technique to quickly and manually debug application, but it is less scalable and more prone to errors. So using this method, it's possible to mistakenly log sensitive information to console, and that's another security issue. Logging sensitive information to the console, you understand, which could then provide malicious agents with private information about customers and all of that. That is another issue. So the key features of debuggers are watching object and adding breakpoint. So by watching objects, a debugger can help track the changes of a variable as a programmer steps through the program. Let's say breakpoints are just markers that the programmer can place in their code to stop the code from continuing beyond point that the developer is investigating. You place a debugger at the top and in the middle. You just want, or before and after a block of code you want to debug actually. So we're going to be learning how to use a debugger on the console, and both on the console and in the browser. So first of all, try it on the console, and then we'll see how we can use it in the browser. The browser has a GUI, graphic user interface. But first of all, let's try the console and then see how we can do this. So what we actually do is let's stop our server, clear it. This has nothing to do with our application. So I'll create, let's say, test.js like this. Test.js. And inside of this, I would like to create an application with a bug. Normally, identifying this bug may be somewhat confusing, because if you look at the code, especially people who are new to coding, when they look at it, they will not be able to spot the error. But let's go ahead and then write, let's say something like const numbers is equal to an array of 1, 2, 3, 4, like this. Then let's see const total is equal to 0. Let's initialize the total to 0. And then we'll write a loop for let I equal to 0. I is less than or equal to nonce length I plus plus. You see total is equal to plus equal to numbers I. We'll come down here and we'll log total. Yes, so then let's test our application. Let's see if our code is working as expected. Say node test.js. Okay, this is let, not const, because we are reassigning it. Run it once more. We're having not a number. So why exactly are we having not a number? So in this case, before I go ahead and debug, use a debugger to debug this, I would like to explain this code. We have an array with the size of 4. So we're writing this, we see we have 0, 1, 2, 3. I is equal to 0, I is less than equal to number. When you log the length of this, you are getting log numbers length. Log it to the console. We have 4. The length of this array is 4. And we have 4 items in it. So the length is actually 4. So what we are saying is, we're saying let I equal to 0, I is less than equal to numbers length. And we start counting from 0. We have 0, 1, 2, 3, 4. Before we get to 4, before we count from 0 to 4, we're having 5. We're supposed to have 5 items in this array. So in this case, we come here and say undefined. So when we start counting from 0, the first item is 1. Second item at index 1, offset 1 or index 1 is 1. That is 0. Sorry, at offset 0 or index 0 is 1. And offset 1 or index 1 is 2. Offset 2 is 3. Offset 3 is 4. And we are saying less than or equal to, that means it's up to 4. So as at offset 4, we're supposed to have an item here, and we're having no item. So if we run this code again, we're getting none, not a number, because undefined is not a number. So when we get to 1 plus 2 is 3, 3 plus 3 is 6, and 6 plus 4 will give you 10. So by the time we add undefined to 10, your result will be none because undefined is not a number. So that's what we are having. Let's say 2 plus undefined. Now we log it to the console. We're having none, none. That is 2 plus undefined. Undefined is not a number, so undefined cannot be added to 2. So there is the issue we're having. So if we change this here, we remove this equal sign, we say I is less than number's length, that is I is less than 4, that is I is 3. So we start counting from 0, 1, 2, 3. We have actually 4 elements in this. And that is how our code is supposed to work. This time around, it will work properly. Oops. Okay, let's remove undefined. Okay, now we have 10. 1 plus 2, 3, 3 plus 3, 6, and 6 plus 4 is actually 10. Okay, so that's great. So what we want to do now is, let's say less than or equal to number's length and come back here. So we're having an error in our application and we don't know where the error is coming from. So we say node inspect test.js. Great. Now let me expand this terminal a little. Oh, and I forgot I've not zoomed in. Sorry about that. Okay, I believe now you can see my terminal and my editor very well. So debugger listening on WebSocket. So they are using a WebSocket to listen to our everything we're doing here. Like this, like for help C, HTTP, NodeJs, org, and docs inspector whatsoever. Connecting to 127.0.0.922. Okay, debugger attached. So back on start, as you can see, the first line here, it's highlighted, the const is in green. So if I hit N, hit enter, as you can see, yes, and it moved to, look at the one here is highlighted. If I hit N, hit enter, we're on the next line, which is 0. We're on the next, we're on line 2, and we have 0 here. So when we hit N and enter, it moved from const to 1 because our code has started from 1 to 1. And now hit enter again, move to line 2. We have our total initialized to 0. So let's hit N, hit enter again. And now we have I equal to 0. Initially, total was equal to 0, I is equal to 0. So if we hit N, hit again, we have our length. Now our code is being executed. I is equal to 0, and I is equal to less than one number's length. So it's in the length. I'm trying to check the length of our array now. If we hit enter, hit N and enter, we're on the total plus equal to numbers I. So let's hit N, hit enter again. But at this time, we don't actually know what's happening. We don't know what's happening. So it is back. Now the total has incremented. So what we want to now, we want to watch our total and the iterator, which is the I. So we'll say watch total. And we'll say watch I. Hit enter. Okay, so now hit impute N, hit enter again. Now, as you can see, the total is 1, the I is also 1. So I want to stop this debugger and run the debugger again. Control C, C. Okay, clear our terminal. Then node inspect test.js. Okay, so now let's watch our total. I also want to watch our iterator. This is I. And enter and hit enter. Reference I is not defined. Okay. Okay, I think I know the reason why I'm getting that error. Gotten to that I. This could at some point before we hit enter. I is undefined, n, enter. And now it's not 0. Oh, and we're having 2 i's. We have to start afresh. Let me just start afresh. And let's of all watch total. Hit n. Our total now is undefined. Watch as total is undefined. Hit n, hit enter again, and total is 0. The reason why total was undefined was because we started at line 1. So when we started, look at where this arrow is pointing. The arrow is actually pointing at line 1 and pointing at the first element in our array. So the total is below this first line and it hasn't gotten to the first line. That's the reason why the total here is undefined. But immediately it gets to our total, as you can see here, total is 0. And if you enter and you hit enter, you can see that the watchers, look at the watchers here, the total is now initialized to 0 because it has gotten to n. And now it has gotten to I. So initially, if I watched I, you see that I will be undefined because it hasn't gotten to I. But now if I watch I and hit enter, as you can see, I is initialized to 0. As you can see, this line is being executed. Now it has passed I and is on the length, and it has discovered that the length is less than 3. So it will have to increment this loop again. It will have to increment I again and increment the total as well. So let's hit enter. And this time around, we've gotten to the total. Now the total will increase because it's executed this loop, the line, and it understood that, okay, the I is still less than the number's length. So it will have to increment this. So if you hit N and you hit enter, what we have here, the total is now 1 because it's iterated and incremented. And then look at this plus. The plus now is highlighted because once the total is increased to 1, the I now will be incremented. So if you hit N, hit enter, I is incremented and it's back to check the length of the array. So once the I is incremented, it's back to check the length of the array. And now if you hit N, hit enter, you see that the length of the array is still less than I because I is 1 and the length of the array is it's actually 4. So I is still less than the length of the array. So if you hit N, you hit enter, you see now the total is 3 because total was initialized to 1. When it got to 1, that is it was 0. So when it iterated and returned the first element in the array, which is the first element in the array is actually, where is it? Sorry, it's actually 1. So at first it returned 1. Now it's at the second element of the array. So the second element is 2. So it add the initial value of 1 to 2, making it 3. Now it's incrementing I. As you can see, this I here, this plus sign is highlighted. If you enter and you hit enter, you can see that I is 2 because it's just incremented I. Now it's checking the number of the length of the arrays to make an increment. Hit and hit enter. So it wants to increment the total now because the length is still less than, the I is still less than the length. So hit N. That is, as I initially said, N is next. So it's at the third element of the 3 to 3, making it 6, and I is at 2. So let's hit N, hit enter. I now is at 3. It's incremented and it's about to increment the total as well. Total now, hit N, hit enter. So we have 10 now. Okay, I now is at 3. But we say I is less than or equal to the number's length, and the number's length is 4. So it will still check. It will have to increment by 1. And we're at the last element of our array, but it will increment by 1 and then add undefined to the array. Okay, so if you hit and now hit enter, it's checking the length. Is watching the total and the I. You are trying to figure out why your application is returning none. And now you are watching your I and your total. Now you discover that The reason why it's returning none is because you have only 4 elements and the iterator is starting from 0. So it must start from 0 and stop at 3. 0, 1, 2, 3. That's your four elements. The offset of 0, 1, 2, and 3, because we only have 4 elements. But here we are saying less than or equal to. So we want our offset to stop at 4, which we add undefined to our numbers and return not a number. Wow. So that's good. We've succeeded in using the debugger to actually debug our program. So now we come here, we can actually use the GUI. What's this? You can see Chrome :/forward expect, then you open dedicated dev tools for Node like this. Okay, so let's move this up. Let's move it there. Okay, that's great. So now look at these icons. We have the step in, step out. I think this is next, and this one here, I think I've forgotten. If you play, let's play. So, pause. No. Source, no, console. We're having none here. I think I should just close this and open it again. Yes. Source. Watch. I don't know this. I'm used to the console. I think we should just stop this and run it again. Come down and say Chrome inspect dev tools. Okay, and we have our dev tools here. Okay, so now look at the nums and the total. We have the global. We don't have anything to do with the global. Let's remove this. We don't have any breakpoints. Okay, so now we're watching the numbers and the total. So let's step to the numbers. Look at where the cursor is blinking. Let's step once more, the next line, and we have our numbers to be an array of 1, 2, 3, 4. So now we have our total undefined, and if we step to the next, oops. Oh. Actually, I'm not used to this debugger using the GUI, and the GUI is actually, I think, I'm not used to the GUI, and the GUI is giving me some problems. I don't know why. It's a pause, scope. So I think you just go on your own and explore the GUI. I'm used to using the terminal here. And as I earlier said about the watch, let's watch I. And now if you hit N, it will give you an error that can only perform operation with post. Okay, because I think that's what's happening. The reason why we had that error. Okay, I think we just stop and then inspect again our file. Then we watch our I like this. Okay, hit next. Reference error I is not defined. Hit N again. I is not defined. Hit N. And actually, this time around, I is defined, but it's undefined. It's I, the variable I it's defined, but it is initialized to undefined. And if you hit N, you see that it is initialized to 0 because now we're executing this line. It's initialized to 0, and I now is less than numbers length because it knows the numbers already, that is checking the length. Okay, if you hit N now, you have your total and all of that. So you're checking for I. So that's great. We've successfully debugged our code, and now we come here and make some changes to it, and then we'll remove this. Say, oh, that's what the problem is. Then we say node test.js, and we have our 10. So that is great. We've successfully debugged our app, and it's working as expected. So that's just how to use debugger. You open a file, and then you try to go over that file and then debug it and know what's wrong, why you're getting an error, and all of that. Okay, so that's just introduction to debugging and all of that. So what next do we have on our list? Here we've introduced profiling, and as you can see, we did not use our application to actually profile anything, or because our application is working as expected. But if in case you come across any error, then you can use this method to actually debug your application and try to execute it line by line, block by block, and even jump into functions by using the S and the O. To jump into a function, use S, and to jump out of a function, use O, and all of that to check your application. Okay, so next is monitoring and logging. Very interesting. Most of you have been waiting for this. Oh, you're not talked about Morgan. You're not talking about why are you not? Oh, okay, so we're at it now. And monitoring and logging. Okay, so what exactly is monitoring? Let's come over to our docs. And we have monitoring and logging. So first of all, we have monitoring. Monitoring involves keeping a watchful eye and its components in real life to ensure they are performing optimally. It helps you detect issues, troubleshoot problems, and ensure that your application meets its performance and availability goals. Here's how to implement monitoring in Express. So health checks, implement health checks endpoint in your Express application. This endpoint can return basic information about the application status, like whether the server is up and running and all of that. Application performance monitoring, there's APM tools. Use APM tools like New Relic, Datadog, or open source solutions like Prometheus and Grafana. These tools provide deep insight into application performance, including response time, error state, error rates, and resource consumption. But we're not going to be doing any of this. I will leave it up to you. If you want to explore these options, you can go ahead and explore it and then integrate it in your application. A log aggregation, send application logs to a centralized system like Elasticsearch and Kibana, that's ELK Stack, or Splunk. This allows you to analyze logs for errors, performance bottlenecks, and security incidents. Yes, for errors and information about what's happening to application. It's essential for debugging, auditing, and understanding how your application behaves. In Express, you can implement logging as follows. You can use Morgan. So Morgan Express middleware is an Express middleware called Morgan that you can use to log SSP requests. It provides pre-formatted log outputs for each request, including details like HTTP method, status code, and response time, and all of that. So if you don't want to use Morgan, you can go ahead with custom login. For more specific login needs, you can create your custom login middleware or use popular login libraries like Quistin or Bonya. These libraries allow you to define log levels like info, error debug, and log message with structured data. So quickly, what we will do is we also learn how to read docs. So we head over to our browser. Then we go to Morgan npm. So we have Morgan here. Click on Morgan. So we published 4 years ago. Wow. You come here, create a new Morgan login middleware, all of that. So the installation, you say npm I Morgan. Come to terminal. See just paste it here, hit enter, and Morgan will be installed. Okay, added 6 packages and audited 181 packages in 3 seconds. Okay, 21 packages are looking for funding. npm fund for details. Okay, we're not interested in finding any package for now. And you can see we have using a predefined format string. We have the tiny using format string of predefined tokens, and all of this, we have other options. Let's move down a bit. We have a combined, we have the stream, predefined formats. So there are various predefined formats provided. We have combined, standard Apex method dealing combined log output. So we have common, have dev, concise output colored by response status for development use. And we have short. Okay, so what do we do now? And you can even see combined and you skip a function, only error responses like this. You see function to determine if login is skipped, defaults to false. This function will be called as skip request response. Okay, that's great. So what you will do here now is we come up, we install Morgan. Morgan is actually a middleware. So what we want to do is say, come to index.js, we import Morgan. Say import Morgan from Morgan. Then we say app use Morgan. Then we have formats. Okay, in here, let's just say we have combined common dev short. Should we say combine, or let's go to dev because we're actually in a development server like this. And apart from that, you can do something like this skip function and the rest. Anyhow you want to do it. The request header, the remote user, the user authenticates as part of the basic auth for the request. The given header of the request, if the header is not present, the value will be displayed as this. Okay. Let's start our server and see. Okay, here's Postman. First of all, login. Login success. Send this request. We have 23 headers right now. Transfer encoding chunked. Specifying the form of encoding used to transfer the entity to the user. Okay. Content encoding. As you can see, this is actually what I was looking for. Content encoding here is gzip. An entity header indicating the encoding method applied to the entity body. So this is encoded, this is compressed, and content encoding is gzip. So our app is actually working as expected. Our rate limit in here, we'll send 2 requests. We've logged the user in after 15 minutes. And now we are starting afresh. We've logged the user in and we've fetched some tasks. So X rate limit is 100 and X rate limit remaining is 98. XS production 0, limited cross domain policies 0, X frame options, same origin and all of that. So strict transport security, max age, include subdomains, same origin, same. We have content security. We have a lot of things here. Okay. Transfer encoding is chunk. As you can see, content encoding here is gzip, and once the content encoding is enabled, the transfer encoding will be chunked, because for you to compress data, it therefore means the data is big in size. So it actually will be sent in chunks. So we're actually noticing things here. We have post session auth login 200, 213.744 milliseconds. Get task 200 milliseconds. Wow. So that's actually great. And our Morgan is actually working. That's great. Let's leave our task here. Leave. Okay, so in this case, let's change this to common and see what we've got as well. Where is it? Common. Let's go ahead and then fetch some tasks. Great. And this time around, you can see server running about 3,000 like this, 17th October, 11.46.22.00 get task HTTP 1.1. HTTP version, the request method and the headers default to this as we read earlier. Okay, so the Morgan is working as expected. So now we're not going to be implementing Winston as we saw earlier in custom headers, custom login. For more specific logins, you can create your own custom login middleware or use popular login library like Winston. Okay, let's go over here and see Winston npm. Then you click on Winston. There's a documentation for Winston. Okay, the recommended way to use Winston is to create your own logger. This simplest way to do this. The simplest way to do this is using Winston create logger. So because Winston is going to require Winston, logger is going to Winston create logger, level is info, format Winston format JSON, data, this and that, blah blah blah. And Winston transport file name this. Okay, and you know what? And if you are not in production, then logger add new Winston transport console format Winston format simple. Okay, that's if you are in development. Okay, I think we should just demonstrate using Winston. Let's stop our server here and say npm I Winston like this. Okay, so now we'll come up here and we import Winston from Winston. I think it should be after Morgan. Import Winston from Winston. And what do we have here actually? See, const logger equal to Winston create logger. What? Let's just copy this and paste it. Like this. And that should be all. Is that all? And down here, we'll do something like app use logger. Let it be app use logger like this. Now let's start our server once more. Okay. App use requires a middleware function. A middleware function. Okay. What are we supposed to call it? Like this. The logger is not a function. Oh, oops. So okay. I think the documentation here is not quite clear, but then okay, there are more configurations down here. I'm using Winston, logger message symbol, message, this and that. Okay, this is actually a custom middleware logger. This. You know what? I've not actually used Winston before, but I know it's used for custom logging. And for that, I think we should just leave it like this. We have common, okay, level info. Okay, so let's just copy this and then see if it works. If not, then we'll apply Winston later. Okay, send requests. Our app is working. Okay, great. So it's working. We're not in production. So our Winston logger is now working. So present env node is not production. Then we logger add new Winston.transport console format, Winston format simple. Okay, nothing is in here. Error. Whoa. We have nothing in our log files. Okay, we have error here combined. The info, write all logs with importance level of info or less to combine log. Okay. So what I will do now is come here, throw new error. Okay. So let's see if we have anything in our error. We still don't have anything. Okay, our application is not running. Or did I throw the okay in the session notes? Okay. Let's remove it and throw it in the async wrapper, I think down here. While fetching tasks, let's throw it in the tasks while fetching our tasks here. Okay, so now let's try to fetch some tasks. Make a request to fetch some tasks. Internal server error. Okay, our server is still running. Then we should have something in our log error, but we still don't have anything combined. Oh, and it's not working as expected. Okay, here get task, but in our Morgan is showing us, oh, we have a 500 error here. We have a status of 500, which is internal server error. And that's great. But for Winston, maybe we'll go learn how to configure Winston properly. But for now, let's just leave it the way it is. Okay, so let's remove this. Make a GET request again once more. And Morgan will show us that, yo, this is a 401 unauthorized. Great. So as you can see how Morgan, and you can even configure Morgan to send this data to some external APIs also, or on the console, anyhow you wish to configure it. But this is just the basics. Now, if you come back and you log in, login success, and if you open up the console, you have 200 session auth login. It's a request, it's a post request. This is the route, HTTP 1.1, and the response status code of 200. So if you try to make a request to get, oops, I'm logging in once more. Okay, so if you're trying to get some tasks, this is actually 200, and you come down here, see, /task HTTP 1.1, response status 200. Okay, so that's basically how to use Morgan and Winston. We tried configuring Winston, but I think we missed out some points. Maybe later on we got to learn how to do that very well, because Morgan is at least more, it's enough for our use case. Of course, we have other tools that we can also integrate with third-party services to check for errors and check for faults in our application as well. So in review for today, we've added much more things in our app. Let's comment out Winston. Comment it out here as well. Okay, so we've added a login to our application. Routing Morgan, login to application, it's a middleware, logs in every incoming request with the headers, method, and every other thing. And we learned profiling, how we can profile our application if you've got any error. And we've learned many other techniques, optimization techniques. Compression, profiling, monitoring, and logging, and how we can do all of this. Okay, so this is great. And our next class, we will be proceeding to optimization techniques too, that is unification and bundling, using streams, caching, and load balancing. Okay, so if you have any questions, you can go ahead and ask. Okay, so if you don't have any questions, we call it a day, and you have a nice day. We meet in our next class on Thursday.